That's right, ladies and gentlemen, it is time for 4.3, but even more exciting is the crazy Mr. Naughton is back. Oh my goodness, hopefully you are well caffeinated or you ran on some energy because the guy with some colors is back. So we are on 4.3. I'm going to do 4.3 part 1 and then part A, so the second part. So batter up, let's roll. We got a review questions first, so let's jump into those bad boys. Our first one is, what is the sine of 4 pi? Now, we just got done using our unit circle, and hopefully you're feeling good. But 4 pi was not on that. In fact, it stopped at 2 pi. Oh, no, it stopped at 2 pi. What are we ever supposed to do? Well, the reason why it stops at a 2 pi, ladies and gentlemen, is because we have a cycle. So if I go, that's 1 rotation, that's 2 pi. If I do another rotation, that is 4 pi. So holy cow, sports fans, if I go around and end at 4 pi, it's as if I really took the sine of 0. So let's go ahead and find out at 0 degrees, our starting position, where we're at. So that point is going to be 1, 0. And if you recall, it goes cosine, then sine. So the sine of 0 is 0. Our answer to number 1, 0. All right, let's go ahead and go back to Mr. Leisman's video when we talked about angular velocity, and that's different from linear speed. But the big part about this is that revolutions per minute is not the form we want it in. We want it in radians per minute, or rads per minute, or seconds. It sort of depends. But generally, radians per minute is the good one. So 3 revolutions means you're going to go around 3 times. Okay, but with each pi, with each revolution, there's 2 pi, or 2 pi radians per revolution. And then we're just going to go in 1 minute. We didn't change our time, so we're going to leave it that way. So that is going to go ahead and give us, hopefully my math is correct here, I was going to put 9. And that all that lead up to put the wrong number, lordy. 6 pi divided by 1 minute. I'm a fan of leaving it in terms of pi, but if you need to be a decimal, then that's going to be 18.85. Booyah, grandma. Alrighty. And then number 3, it says, what is the cosine of 0? So, cosine of 0, we're going to go ahead and be right there on the axis at our starting point. That is a point 0, 1. And remember, it goes cosine, then sine. So, ladies and gentlemen, that is going to be the number 1. Alrighty, some solid review today. So let's go ahead and take a look at our actual notes for the day. I'm going to reduce this to reduce the clutter. Hit the rewind button if you need it. Alrighty, it says our goal today is to solve for the sides. That's not the highlighter. Solve for the sides and angles of our right triangle as well as label bearings. Now, what you're going to notice is that this bearing stuff is not in your textbook. We added it because it is super critical for stuff we do later. But also, this stuff should be stuff, hopefully, you remember from formal geometry. We all remember this SOHCAHTOA. If you're not, go ahead and hit the pause button and hit Google SOHCAHTOA, and it'll come on back. But it just tells us how to set up our trig functions. So S obviously stands for sine, and then O is opposite, H is hypo, A is adjacent, okay? So, ladies and gentlemen, this is going to be super important for us today, and when we set up our sides, crucial, okay? So let's go ahead and write this up. So sine is obviously going to be opposite over hypo, okay? Cosine is obviously going to be adjacent over hypo, as we just mentioned above. And then tangent is going to be opposite over adjacent. Alrighty. Ladies and gentlemen, we have some reciprocal identities that are super important that are going to come into play. And ladies and gentlemen, those reciprocal identities have to do with cosecant, secant, and cotangent. Okay? So something to rewrite down, is that cosecant is related to sine in that it is the reciprocal. So if I say it's 1 over the sine, that's going to take this fraction right here and flip it on its head. So hypo over opposite. Alrighty. Our secant is going to go ahead and be related to 1 over cosine. And so that's going to be hypo over adjacent. We're going to flip that fraction. And then cotangent, ladies and gentlemen, is going to be 1 over tangent. And tangent is adjacent over opposite. So we're going to flip it. Boom. So, ladies and gentlemen, boys and girls, if I were you, okay, and this is to be straight up honest with you, I would start looking at some identity parts for this trigonometry unit. We sort of alluded to this in Chapter 5 and Chapter 6. We're really going to get into these identities. So if you ever go ahead and just Google, and you can really pick up anything, trig identities. Oh, look, it's the first one that comes up. Beautimus. You're going to see a bunch of images, stuff we'll talk about, reciprocals. Let's even look at this one here on the corner. Reciprocal identities, Pythagorean identities, cofunctions, we're going to get into those. Not so much into these odd and evens, but the quotient identities. I would go ahead and start committing these to memory, or at least be very familiar with them, because they're not going to go away. And as you can see, we're going to start adding to them with odds and evens, halves and doubles, laws of sines, laws of cosines. Don't get so freaked out to memorize them now, but just realize that that's coming. So this, what we just wrote down in our notes today as we flip on back, is going to be one of those things like the importance of a unit circle that we need to have ready in our tool belt to use at a moment's notice. So speaking of use them in a tool belt, let's get rolling. Okay, so we are going to be looking for these trig ratios, because that's what sine, cosine, and tangent are. They are ratios of sides of a right triangle. Okay, so again, we are dealing with sides specifically. Okay, now what you notice about this right triangle is, one, we have Bath Math grammar. We don't have our right angle box right there. We need one. Okay, and then ladies and gentlemen, I hope you realize that this is a 4. I'm going to make it much bigger so I can see it. And this is a 3. But I'm missing this hypotenuse. So we're going to use a very famous dead Greek guy formula. We're going to use Pythags to make sure we have all the sides first. This is going to be crucial, sports fans. So we called this C in our a squared plus b squared is equal to c squared formula. So 3 squared plus 4 squared. Hopefully you realize that this is a Pythagorean triple, and you don't even have to write this out, but just in case, we're going to go through the motions. And then because it's a c squared and I want a just c, take the square root of that, which is 5. So I'm going to erase this and say you are a 5. Cool? Now, back in formal geometry, you really got to be specific as far as which angles you're going to use. You're never going to use the hypo. Never use, sorry, not the hypo, excuse me. That's not what I was trying to say. Never use the 90-degree box or your right angle. Okay? That is not going to get you what you want, because then you're going to go back to points on our unit circle like 0 and 1. That's not going to be as helpful. Okay? So we are going to use a specific angle. So if we notice here, all these are A. So A is where I'm going to go ahead and put my Greek letter theta, as in my target angle that I'm going to use. I'm going to label appropriately. Opposite is the farthest away. That is not the hypo. And we already said that this is the hypo. And so that means this is going to be our adjacent. So I'm going to erase this to declutter. We already know where we got it, or we can hit the review button. But I just want to have everything ready for us and not so crazy that we can't focus. Alrighty. So again, we're going to go back up to our trig functions up here and say, what are we looking for? So sine is going to be opposite over hypo. So if we look at that relationship, again, the opposite is 4 and the hypo is 5. So this would be simply a fraction of 4/5. Now, I would get in the habit right off the way of saying, hey, if the sine is 4/5, then the cosecant, or the flip of that, is going to be hypo over opposite. So do that right away and just flip it. Make it easier for yourself. Cool? Alrighty, ladies and gents, next cosine. That's going to be adjacent over hypo. So our adjacent side here is the 3. So 3 divided by 5. The secant is the reciprocal of that. So this is going to be hypo over adjacent. So that's 5/3. Okay. And then, ladies and gentlemen, we're going to have tangent, which is opposite. Let me change my color. Sorry, I thought I picked blue. Opposite over adjacent, because that's the TOA part. So our opposite is 4. Our adjacent is 3. The cotangent, our reciprocal, adjacent over opposite, which is going to be 3/4. Okay. So to highlight, your trig identities are what they are, and your reciprocals are going to be the flipped version. That's always the case. So that's why you do sine and then cosecant. Cosine and then cosine and then secant, and then tangent and cotangent. Alrighty. So ladies and gentlemen, I would have you guys hit the pause button and try this one. But we are going to get some radicals. So if you're feeling good on rationalizing your denominators, then hit pause and give this a shot. If not, let's jump on in. So it says the AC here is 3, and it says the AB right here is 7. So what I am in the same boat as I was before, I'm missing BC. So we're going to call this the B. It could be A or it could be B. Doesn't matter. A squared plus B squared equals C squared. So 3 squared plus B squared is equal to 7 squared. So 9 plus B squared is equal to 49. So B squared is equal to 40. And then square root, boom, boom. Factor tree. I know not everybody's a fan of the factor tree. I love it. I can't get enough of it. I'm not going to lie to you. So B is going to be 2 root 10. I know Mr. Mortara would say, look for square roots, no factor trees. I just love it. I'm sorry, Mr. Mortara. Don't tell him. So this is now 2 root 10. All right, let's look at what we got here. In all these cases, we're going to use B. So that's going to be nice, because then we're going to go ahead and label that B with our Greek letter theta. We already said that this is the hypo. This is the farthest away that's not the hypo, so that's the the opposite. And then this 2 root 10 is the adjacent. Cool? All righty. So, ka, toa. The nice part here, ladies and gentlemen, is now that you've written that out, you don't have to write opposite over adjacent. Just saves you some time. So that is going to be the opposite over the adjacent. So that's going to be 3 over 7. And then we'll go ahead and go over to the other side and just flip it. Cosine is going to be adjacent, so 2 root 10 over 7. And this will be 7 over 2 root 10. Warning! Warning! Danger, Will Robinson! Danger! Let's put a little reminder down here. There's no radicals in your denominators. I always tell my freshmen when we're doing this, dividing comes, or fractions come from dividing. If you have a square root in your denominator, you're putting into groups of decimals. And if you had 10 puppies, why would you go ahead and put them in a decimal group? One of your puppies is not going to do well. So this is a root 10. That is the issue. So what we're going to do is you're going to multiply the bottom and the top by that root 10. So we get 7 root 10 over 2 root 100, which is going to be 7 root 10 over 20. Because 2 times 10, which is the square root of 100, boom. So this one is why we did this example specifically, is it doesn't look like they're reciprocals. They are, but we do have rules when we have square roots in our denominators. All right, I digress. Next one. TOA, opposite over adjacent. So opposite is 3, adjacent 2 root 10. Danger, Will Robinson, danger. Square root in the denominator, rationalize. All right, I'm going to erase this for clutter's sake. So 3 root 10 over 2 root 100. So 3 root 10 over 20. So, ladies and gentlemen, boom. That is our tangent function. Now, what I do before I go ahead and just flip this, because then you're going to have another denominator to worry about with a square root in it, go back to the original function and flip that. So this is going to be 2 root 10 over 3. Oh, thank you. We're good. No rational denominators. You're good. Gravy? Love it. Ladies and gents, you're going to turn to the next page or scroll. I'm going to do the same thing. I made a nice little page sound. I don't know if you caught that. We have a little bookkeeping right here, sports fans. In that bookkeeping, you can't see that there's a 4 right there. Got erased. And that this 7 is supposed to be that one right there. So, ladies and gentlemen, let's go back. It says, find the measure of angle B. So this is a little bit different because we're looking for an angle in decimal form and then in DMS. Okay? So, ladies and gentlemen, boys and girls, the idea here is we're looking for this angle. So that's my theta. So let's label hypo, opposite, adjacent. Now, if, sports fans, you feel like you want to find that other side, you totally can. You do not have to. Okay? Because we know a trig function through our SOHCAHTOA that is going to allow us to find that angle using the adjacent and the hypo. So which one uses an A and an H? That is cosine. So we're going to set this up as the cosine of some angle theta is equal to adjacent over hypo. Let's fill in what we know. Cosine, some angle, not sure, is equal to 4 over 7. Now, because we are looking for an angle, ladies and gentlemen, we're going to use our flipped triangle identities known as our inverse identities. I'm going to pause for a second. Apologize for the delay. I had someone walk in the room and just wanted to chat with them really quickly, so we are back. So again, we're looking for that theta. Now, because we're looking for that, we're going to use our inverse trig. So you guys remember this trick. You go inverse, so -1 of 4 over 7 is equal to your angle theta. So basically, you use your same trig functions, but you use regular sign for sides. We'll put an arrow there. That's the worst arrow ever. But you use your inverse sign for angles, and we're going to talk more about that in just a second. So when you put that into the calculator, okay, make sure it's in the right mode. Okay, so we're going to hopefully have my calculator work here. Nope, it's not working. So rather than fuss with it, I'm just going to go and jump in and say with the calculator, this is going to be 55 point, look over there, 1500. So I'm going to call it good at saying 15. Okay, so that is the decimal form, but this other thing is DMS. That stands for degrees, little circle up there for degrees, minutes, seconds. So we'll talk more about that when we get to bearings, but the idea is that not everything is degrees, and there's fraction of degrees, so that's what minutes and seconds are. So I need to go ahead and look at that. So we obviously know it's 55 degrees, right? Because we have the 55 right there. And then it says, well, what about minutes? Well, we know this. How many minutes are in an hour? There's 60 minutes. So what we're going to do is you're going to take this decimal, that 0.15, and you're going to multiply it by 60. Okay? So we're going to get, in this case, 9. Now, if there was anything left over, point blah, 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 blah. If there's anything left in this, we would have to do the same trick with seconds. We would take that decimal, times it by 60 for our seconds, and then boom. But since we don't, it goes in nice evenly. We're going to say it's 55 degrees, 9 minutes, and then 0 seconds if you want to get real fancy. The 2 tick marks is for seconds, but we'll just stop there. Cool? So that's our DMS for degrees, minutes, seconds. All right. Given, ladies and gents, 2 parts of a right triangle, you're going to use your either trig functions, your regular trig, or you can do Pythags. Okay, it depends if you're trying to find the sides. Okay, but if you're trying to find an angle, that's where you're going to use your inverse trig functions, or like the sine -1. Cool? All righty. So you need to know what an angle of elevation is. A little review of algebra. So there's 2 angles that you need to know. Elevation is when you're looking up, so that's your theta. Always write that if it says elevation. If it says depression, that means you're looking down. This is your theta. If you remember one thing for these word problems, that is the super important it. So what I would do is if you have a word problem, search for that angle of elevation and then draw your triangle right off the bat. Like here on number 4. Now the nice part about number 4 is they bold it for us. Boom shakalaka. So draw that triangle straight up. So this would be my theta, but it tells me in this case what my theta is. It's 50 degrees. So Ben is looking up at an object at the top of a building through the angle of elevation of 50 degrees. If he is 70 feet from away from the base, so obviously we would call that the base, how high is the building? Okay, we have it all set. We're going to label. This is our opposite. This is our adjacent. Now, we're looking at how high that building is, so that's a side length. So we're going to use our regular trig function, specifically our tangent function. So tan 50 is opposite over adjacent. So we're going to multiply both sides by 70 to solve for x. So I get 70 times the tangent of 50 degrees is equal to x. Okay? When you throw that in the calculator, you're going to get something fancy like 83.423. Now, ladies and gentlemen, one of the things you can do when you're doing trig functions that's super helpful is, does your answer make sense? And a little bit of a review is that the highest angle of a triangle is always the longest side. So an example, this right here is the 90. So this is the hypo, that's the longest side, right? But then it goes in order. So this is 50 degrees. We remember 180 degrees in a triangle. So if that's 90, that's 50. This is 40. So that means this needs to be the next biggest. So that means that this 40 right here is the smallest. So let's look at our answer. Is that the smallest? No. The 70 is the smallest. So your answer probably is right. It probably makes sense. You're probably good to go. And since they tell you how they want you to round, boom, 83.4 feet, and you're done. All right, next one. Scan, scan, scan. It tells you angle of elevation. We're looking up again. Booyah, Grandma. It says 68 degrees. Wonderful news. Oh, wait. It also has a 52 degrees in there. How does that work? Well, that means we better have two triangles if we have two angles of elevation. So that's going to be 52. All righty. These are my favorite types of trig problems because the algebra is saucy. Now, as a heads up, a warning. Don't do the algebra until the last possible second. Stay away from calculator rounding errors, okay? So, but if I lose you, whenever you do tangent 52 or tangent 68, just put it in the calculator and do the decimal. But again, you are looking at rounding issues, okay? So, we now know what we have because we have two angles. We're now going to cruise on. So, we're walking down towards a landmark. Initially, the angle of elevation is 52 degrees. Okay, this is our initial. And then we walk 100 feet closer. And then we're at 68. How tall is the building? So in both cases, we're looking for how tall it is. So let's put an X there because we're a bunch of pirates. We're always looking for me buried treasure, which X marks the spot. Now, ladies and gentlemen, this is where we are currently. So I'm going to put a Y. And then on the other side, I'm going to do y plus 100 because we were 100 feet away. No, I don't need to take a screenshot, but thank you. So what we're going to notice is that, ladies and gentlemen, is I have the opposite side, which is both x, and the adjacent side, which has to do with y, but we have different trig values of 52 and 68. Now, I'm not going to bring in the hypo because I already have enough x's and y's in my life. So when I set it up, we're going to have tangent 52, as mentioned over there, of x over y plus 10. Probably put y plus 10 in parentheses. And then tangent 68, x over y. Now, as we can see, this is a y plus 10, so probably not an easy thing to get by itself. But how about an x? Because if I have an x in both equations, well, ladies and gentlemen, if I isolate that x, multiply both sides by y, then I'm going to get y times tangent 68 is equal to x. And then over on this side is going to be y plus 100 y plus 100. Because again, those denominators would cancel. So I get x is equal to y plus 100 tan 52. Now they're both equal to the same x. So that means by the transitive property, a lot of geometry today, I can set these parts equal to each other. So y plus 100 tan 52 is equal to y times tan 68. Now, again, this is where I mentioned before. If you are having issues, put the tan 52 and the tan 68 in the calculator. Then it makes a little bit more sense. You are going to have rounding errors, okay? But if it makes more sense to you, then do you, okay? Now, eventually what I'm going to need to do is I'm going to need to get all my y's on one side because currently they are separated, and that's not going to work for me. So what I'm going to do is I'm going to distribute this tangent. So I get tan 52 plus 100 tan 52 is equal to y times the tangent of 68. Now, that 100 tan 52 is just a number. It's a constant. Oh, forgot my y in that first place. Let's fix that. There we go. Now, again, y is on the same side. So what I'm going to do is I'm going to bring this over by subtraction. Minus y tan 52. Minus y tan 52. This is going to drop, so it's 100 tangent 52. Is your handwriting, is your hand hurting yet? We haven't even gotten started, sports fans. Y times tangent 52. Alrighty, now we have both of y's on the same side. Now, both of those terms have something in common. They have a y. So I can greatest common factor out that y. So I'll get y times the tangent of 68 minus the tangent of 52. And that's equal to 100 tan 52. So, ladies and gentlemen, this is just one giant decimal, albeit saucy. That's what it is. So we can divide both sides by that saucy decimal. Tan 68 minus tan 52. Tan 68 minus tan 52. So, oh lordy, I'm already on the next page. So y is going to be equal to 100 tan 52 divided by tan 68 minus tangent 52, which, drum roll please, you put that into the calculator, hoping that my math is correct, is 107.095. I always round to the third decimal place. I like to round to if it's like nearest 10th, I do that at the end. Some people say don't, but that's what I do. All right, well, that's y. We're a bunch of pirates, so we're looking for x. So I'm going to plug this back in. Now, focusing back in on this blue formula, which one looks easier to substitute it back in? And the answer is that one. So tangent 68 is equal to x over y. And y, we know, is x over 107.095. Lordy, I've done this so long, I am running out of battery. That's bad. So we'll multiply by both sides, and x is equal to 265.069, or with rounding, 265.1. Woo-hoo, Lordy! Love it, love it, love it. All right, I'm going to hit pause and get my power cord. And I'm back. All righty, hopefully with power. Cool. The last thing we are going to talk about today is bearings. I'm going to try to go through this a little bit quicker, just because the meat and potatoes is what we just got done doing. This is a fun application. First thing I do want to mention here, I'm going to move this up to the side, is when you guys make your bearings, remember north, south, east, west. Okay, make sure that that is prominent there. If you're not sure, always go with that. So, bearing is an angle written in the form of north of west or north of east. Sorry. And then south of west, southeast. Basically, the gist is that north and north means you're going to go up. And then left, if we look at west, that means you're going to go the left. And then east, obviously E over on this side, you're going to go to the right. Okay? So you have to decide if you're going up and to the right, or south, which would be down and obviously left, or down and obviously right. Cool? So first step, north or south, up or down, then left or right. So let's take our first one for a spin. So north means up 45 degrees, north means up, and then from that, we're going to go west, which is to the left, 45 degrees. So up, that's the worst up ever. So north, and then from that, I'm going to go 45 degrees towards west. So I'm going towards west. And so what I'm going to do is I'm just going to draw on this dotted line because this is where we are now. So I went 45 degrees that way. Now, what's super important is that we're going to draw what we remember from the unit circle is your reference triangle. So your reference triangle would be boom, 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 90 degrees. So if we went 45 degrees, that means this is 45 degrees. Okay? So all we're doing is just drawing, but eventually reference angle is super important. All right, let's go to our next one here. I'm going to erase just to give us some room. So north first, because obviously we have our north, and then I'm going towards the east. Okay, east is this way. So going 55 degrees here. And you just sort of eyeball it, and then draw in our triangle. So you went here 55 degrees, okay? This would be our reference triangle right here, and then this lovely reference angle would be 35, okay? Now, again, the reason why we're talking about bearings is right triangles, okay? Just like we had the right triangles before. Alrighty, south. Time to go south. It is getting close to the winter. So south, boom, because it's the south, and then towards the west, right that way. So I'm going to open this way. So I went 35 degrees. Okay, and so then this part is going to be 90 minus 35, which is 55 degrees. All right, ladies and gentlemen, your job is to go ahead and do the next one. So hit the pause, do it. I know it's been a long video, but give it your best. All righty. So, ladies and gentlemen, we're going south first. We're opening up towards the east. We're going 22 degrees. So then make your reference triangle. Remember, reference triangle always towards the x-axis. So this is going to be 68 degrees. Cool? Well done. Well done. All righty. Let's get on a boat. Bring your flippy floppies. Captain Noobs on our boat. A boat leaves the entrance of a harbor going 35 bearing north, 43 of east. Then turns 90 degrees and goes 19 at that time. How far is Captain Noobs from the harbor? All right. So let's make our life easier. So we're going to start here. Boom, shakalaka, boom, shakalaka. And I'm going to say that this origin right here is my start at the harbor. Okay, or else this is going to get even saucier. All right, so we're going to go north. Boop, 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 boop. Okay, then we're going to go, obviously, east. East is this way. North. Boop, 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 boop. So this is 35 degrees. Gravy? Not 35 degrees, 35 miles. Now, ladies and gentlemen, this is the kicker, 90 degrees. Well, if I turn 90 degrees, ladies and gentlemen, that is a right angle. Super important. So ladies and gentlemen, boys and girls, what I'm going to do is I'm going to go ahead and say that we're going to go ahead and go now this way. Boom, 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 boom. 19 miles. Okay? Because we have a new heading. Okay? But the important part is, once again, once you make that turn, 90-degree box. Okay? So then, ladies and gentlemen, this is our new spot. Well, what does that look like to you? That looks like a lovely right triangle. So let me rewrite. 35, 19. How far is you from the harbor? Hypo. So 35 squared, 19 squared, x squared. Always going back to those lovely right triangles. Okay? Now, ladies and gentlemen, boys and girls, those are some big, fatty numbers. So let's just jump to the answer. X squared is equal to 39.824. Cool? So we now know that's how far we are from, sorry, not x squared, x, from our original harbor based on that. Okay? Alrighty, ladies and gentlemen, boys and girls, what is our bearing from the original harbor entrance? So obviously we're still in the first quadrant. So I went originally, boom, that 43 degrees. Then I had a new heading continued. I have a new theta. So really my heading is 43 degrees plus my theta. Okay, so if we look at our right triangle, that's our theta. So let me draw it again. So 1935. I'm not going to use the hypo just in case I made a mistake on the hypo, which I didn't, but just because these are also nice clean numbers. So opposite, adjacent. So to find that, I'm going to go tan inverse, because I'm looking for an angle, of opposite over adjacent because of our TOA. And so when we get that, we're going to go ahead and get about 28 degrees. All righty. So then I'm going to go 43 degrees plus 28 degrees is going to be 71 degrees. Let me double check that that is indeed 20. Inverse tan, 19 divided by 35. Let's be a little bit better about this. I apologize. I know you're like, I've already been here for forever. But this is 496. So 0.496. So 0.496. But wait a minute, and this is also why we need to do this. It says to the nearest second. So remember, we got to bring out that DMS. So I'm going to take that 4.96 and multiply it by 60. This is the minute part. And so 0.496 times 60 is going to be 29.76. So my minutes are 29, and that 0.76 is seconds. So we'll do 0.76 times 60, because there's 60 seconds in a minute. So 0.76 times 60 is going to be 45.6. So, 0.496 equates to, in the nearest second, that's why we had to erase this, as I didn't read directions, if I want to be completely honest. So it's going to be 71 degrees, 29 minutes, 45 seconds. Boom. Boom. If you just round it and leave it 29, like I did in my bad math, and I knew something was funky and then realized it said near a second and said, oh, better get that calculator out. Ladies and gents, this was a lot, and I truly appreciate you spending a whole pretty much day with me on this one. But the big kicker is this part right here. Okay? Really focus on it. Really get to remember it. It's important. This is Mr. Naughton saying, sorry for the length. Catch you next time.